Hi, in this video, I will be showing you problem number 4 of chapter 12, section 2. Write each combination of vectors as a single vector. A. Vector AB plus vector BC. B. Vector CD plus vector DB. C. Vector DB minus vector AB. D. Vector DC plus vector CA plus vector AB. The following figure is given to us. So let's use the triangular law. If you have a vector AB starting from A, the initial point is A and the terminal point is B, and you have another vector BC whose initial point is B and the terminal point is C. Pretty much the vector BC starts off at where the vector AB ends, and then the sum of the two vectors is A to C, AB plus BC is A to C, which is the initial point of the first vector to the terminal point of the second vector. Okay, so it's a directed line segment starting from the initial point of the first vector and connecting the terminal point of the second vector. That is how the sum of two vectors work. So AB plus BC, so if you notice here, it is starting from A and ends at B. The second vector starts at B and ends at C. So the sum of the two vectors is going to be equal to the line segment connecting A to C. So the first part of the problem is actually AB plus BC is AC. We need to remember that it is the starting point of the first and the end point of the second. Now part B, it is a CD plus DB, vector CD plus vector DB. So in the figure, it is vector CD, then vector DB. So if you notice, the second vector starts at the terminal point of the first vector, and therefore the resultant of these two, the sum of these two vectors is going to be starting from the initial point of the first, connecting to the terminal point of the second, which is nothing but CB, vector CB. So remember like this, starting point, the end point, CB. Then part C, DB minus AB. So here, DB minus AB, we can look at it like DB. The negative of AB is same as positive of BA. Now it is addition of two vectors. So it starts off, the sum of these two vectors is starting from D, the initial point of the first vector, and stop at the end point of the second vector. So which will be DA. Right? So in the figure also we can confirm that. So it is DB, DB is this vector, and then BA is this vector. So the resultant vector, the sum of these two vectors will start at the initial point of the first and end at the terminal point of the second, which is equal to DA. Part D, DC plus CA plus AB. So DC, so we can actually combine them into two parts. So it is DC plus CA, and then we can combine it with AB. So these are sum of two vectors. So sum of two vectors is initial point of the first to end point of the second, so which is equal to DA. So we'll also look at it in the picture. DC plus CA. So DC plus CA is nothing but DA. It is this vector. This is the first part. Then we are adding to the vector AB. We are adding to the vector AB, so it is this vector. So we have dA plus AB. So if we use the rule d initial point of the first connected to the end point of the second, terminal point of the second, which will be nothing but dB, which actually agrees with this figure also. Hope this video helps.